Assalamualaikum. So today I would like to present my assignment. So the first question is sketch the magnitude response for the low pass filter. So you guys can see the graph. So the formula that I use is 2FC sin WC bracket n minus alpha per WC n minus alpha. So this graph shows the magnitude response of an ideal low-pass filter. Along the horizontal axis is the frequency, and the vertical axis shows the magnitude. In the pass band, from 0 up to the pass band HWP, the magnitude is close to 1, meaning all low frequency are low. Between WP and the stop band HWS, we have a transition band where the magnitude gradually drops. Beyond WS, in the stop band, the magnitude become very small, either 0, which means high frequency are attenuated. The weight between WP and WS, we call that the transition weight. The response is designed using a ideal response formula shown on the slide. So the next question is sketch the coefficient of an FIR low pass using a Henning window method. So you guys can see the formula that I use. First we need to find the value of FPN, delta Fn, and then Fns. So the formula for window function is 0.5 minus 0.5 cos bracket 2 pi n per n. So and then we need to find the value of delta F n dengan n and alpha. So the last question is calculate the causal FIR for an order of n equal to 32 until n equal to 34. So the formula that I use is sin WC n minus alpha per n minus alpha bracket 0.5 minus 0.5 cos 2 pi n per n. So for the example, you guys can see the value of 32. So we need to find the value of 32, 33 and 34. So for question 2, first we need to determine the selectivity factor K, discrimination factor D, and filter order N. So first we need to find selectivity factor K equal to omega P per omega S, and then discrimination factor D equal to square root 10 Rp per 10 power of Rp per 10 minus 1, and filter order log D per log 10 per log 10D per log 10K, and then we can find the filter order. So the next question is determine the 3-bit cut-off frequency omega C to any value within the range. So first the formula is omega P per 10 power of Rp per 10 equal to 1, power of negative 1 per 2n, and then omega C omega S bracket 10 power of AS per 10 minus 1. So and then the last question is determine the system function based on calculated left hand side LHS. First we need to find the PN equal to omega C exponent J power of n plus 1 plus 2n pi per 2n, and then n equal to 0, 1, 2, and then we need to find the value of P0, P1 and P2. So you guys can see the example that I show on the slide. For example is P0, and then for the last HS n minus 1 per omega c power n per s minus pn. So that the last formula, so using a MATLAB, we use the coding that I showed to you guys. So for the I can explain to you guys step by step. So for the first graph, this is a design parameter for the filter, and then the second paragraph, WP not, this is a MATLAB filter design functions, and then bracket n wn, and the minimum filter order needed, and wn the normalized cut-off frequency, and then the bracket b e, this b is numerator and a denominator, and then post rows a, calculate the pole of the filter transfer functions, and display result fprint and all, show key design parameter and pole in the comma window, and then pole the frequency response is figure, freeze plot the magnitude and phase response, and FV tool open the detailed filter analysis tool. So the result that I get from MATLAB, this is a result for magnitude response, and then this is a result for a phase response. So that's all from me. So thank you.